the APAN-GNAG routing working group addressing global routing. I'm also joined by my co-chairs, Warwick Mitchell from ARNet and Hans Edelman from Indiana University. So today is just going to be an overview of the APAN-GNAG routing working group, where we're at, where we want to go, and some tools that we use to look at these cases. For those of you that have not been to a routing working group meeting, I hope this is informative and you send out the information to any colleagues that may be interested in working with the group or joining the group. And for those of you that have been here before, thank you again for joining us, and feel free to join in the discussion or ask any questions in chat. Hans will be helping me, Hans and Warwick will likely be helping me with the chat, so feel free to put any questions you may have in chat, and we will go ahead and get started. The APAN-GNAG routing working group was established in June 2021. It was established to create a community to work on international routing issues to improve R&E performance. Overall, the goal is to engage not only network engineers, but network owners, NRENs, and other network users to not only react to and discuss ineffective routes, but work to proactively use this community to create policies and prevent ineffective or anomalous or inefficient routes from occurring within our community. And also just having a better community to go to when we see these routes, and a community to work with when we need assistance throughout the international community. Our current status, we have over 170 members now. I think we're actually up to 174 as of today. Over 20 countries represented and 120 institutions. Since 2021, we've solved 18 total cases, or we've had 18 total cases, and we've solved 15 of them. 2 cases are on hold pending upcoming links, and 2 new cases have been created since the January meeting. Overall, our goal is to do about 10 cases per year. And we started in June 2021, so that's about, we're coming up on 2 years, so that's about right as we go into June this year. 10 seems like a good number, as these cases take some time to solve, and it requires the collaboration of a number of NRENs, a number of engineers, and a number of people across our community in order to look at these routes and determine if they are worth working on, and then try to solve them. So thank you all. For those of you on the call that have worked on cases, we wouldn't be successful without you. For a visual, just an interesting visual on all the different countries, and just a visual representation of the diversity and the participants that are in this routing working group. We have a number of countries, a number of geographic areas throughout the world. I think it's very interesting to note how many people we have from all different places across the world working together to look at and to educate ourselves through tool talks, and to look at some of these cases to improve the performance of our data transfers and our routes across the world. So some of the international routing challenges we've observed since 2021: asymmetrical routing, R&E data that takes a less efficient route around the world, affecting performance. The 2 primary cases that we see in this instance are Europe to Asia routes traversing the US, which will have effects on latency and round trip time. Africa to Europe routes traversing the US, the same issue. R&E data that takes a commodity route when an R&E path is available. As many of us know, or if you don't know, R&E networks are tuned for large data transfer performance and for performance in general, whereas commodity is just tuned to work, and they don't really care what path it takes and whether it performs to the level of some of these necessary for some of these research and experiments. New links are removed or added, but the routing does not adjust appropriately. We all know BGP works, but sometimes it doesn't do exactly what you think it's going to do, and it's important to take a look at those paths and make sure that when new paths come up or are removed, that the routing changes appropriately and the way that you think it's going to be. Leaking of private ASNs into the global routing table by R&E networks. IP blocks advertised with a Bogon origin ASNs within the R&E routing table. And then a new one this year is routing loops. We have two primary goals as the routing working group. This year, we're definitely going to be focusing a little bit more on the policy focus, but to start, we have the engineering focus, which is to document possible erroneous routes, identify teams to address them, and check in together as we work through them. So we are actively doing this with our 18 cases, identifying the teams to address them, and then we have monthly meetings to check in on the progress of these cases as we work through them together. A lot of the work, the engineering work, is actually done over Slack or email, but we do check in monthly as to how those cases are going and what the next steps are. We also have a policy focus. So detailing routing policies for paths, this includes preferred backup paths, and then actually verifying if that policy is being followed. As I said earlier, sometimes we, as engineers, configure things, we think it works, but it may not do exactly what we thought it was going to do. In addition to this, we're working on some best practice policies this year to send out to the community and have on our website for new engineers or just general R&E engineers to take a look at as they go and troubleshoot common issues that the routing working group has worked through in the past. That's a large focus this year that I will talk about a little bit later. Some of the tools, some of you may be asking, how do we do this? How do we document these erroneous routes? How do we find them? And what do we do once we find them? Some of the tools that we use are NetSage, which I will be going over a little bit, but this gives you access to flow, SNMP, and route information. For those of you interested, there's the link right there, but I will, like I said, we'll go into it a little bit. Easy to find data on rate and volumes, and it can also give you clues as to routing information as well, and that's what I will be focusing on later today. Some other tools: traceroute, route views peering, router proxy looking glass, perf sonar. We just did a large engagement with RIPE Atlas. We're looking at having them take a look at how we can better create dashboards and other items for R&E specific data. So we've been working with them. We met with them last week, and they've taken some of our recommendations back, and they will be coming back with some new ideas for new dashboards or ways to use that platform to help us solve some of these issues. And then PeeringDB. We've had them come and do quite a few tool talks. As I said, this is NetSage. So this is the APONET NetSage dashboard. Many of you are familiar with APONET. It's a coordination of a number of NRENs and network providers throughout the Asia Pacific area. And this is their NetSage dashboard. This is the last 7 days. You can see what those links are doing, how much data is over them, and how much data has been transferred over the APONET links. And so that's just a quick look at the APONET dashboard. NetSage uses data sources flow from routers, which is a passive collection. It is de-identified. SNMP data, also passive. So this is just basic bandwidth data. Perf sonar, which is active testing between sites. And TSTAT, which is based on traffic analysis for archives, which is a passive measurement, but necessary for some of the older sites or sites that don't want to do SNMP or flow data. We use NetSage a lot within the routing working group, as it's a tool that I often use to present some of these routing case anomalies, and I'll show a few dashboards later today. NetSage was created to answer some of these questions. So what is the current state of our network? What are the top sources and destination of flows? What are the top flows by organizations? However, in the use case of this group, we're actually using NetSage to identify possible erroneous routes, and then dig in deeper with things like traceroute, perf sonar, RIPE Atlas to determine if there is asymmetric routing, a commodity internet route that's affecting data transfer performance, or any of the other things that I mentioned earlier in the presentation. So not only can you answer some of these questions with NetSage, you can also use it to solve some of these routing issues. So now I'm going to go over some previous cases that we worked on that highlight some of those issues that we've seen. And then I'll talk about the 2 cases that we have open. So the first one is R&E traffic using a commodity route. This is ITB, which is in Indonesia, to Starlight in Chicago, the United States. So the route from ITB to ESNet Chicago was using R&E networks via TANE, Transpac, and PacWave. However, in the other direction from ESNet to Indonesia ITB, it was using PCCW, which is a commercial path in the US and other commercial paths. So actually this was preventing access to the Starlight DTN from Indonesia, as ESNet needs to be accessed by RNE networks only. So we worked with ESNet to update the accepted routes from Transpac to use the RNE path. The trace routes are now symmetrical, and the engineers have confirmed that they can access the DTN. So we worked with ESNet engineers, Singaran engineers, ITB engineers, and myself to take a look at this case. So this is a good example of commodity traffic versus RNE traffic. The second example, asymmetrical routing. We identified this issue, Singapore to New Zealand, traversing the US, and was asymmetrical. So there was actually two issues here. Singapore to New Zealand is another one of those, Asia to Australia, Asia to New Zealand. We should not be traversing the US. That is a much longer path, much longer round trip time, causing performance issues and causing latency as well. So if you look at the paths before we changed, it was Singaran. One of the paths went from Singapore to LA, to Internet to LA, down to Rayans. And then the way back actually went from Rayans, Transpac, APAN, and Singapore. So neither of these seemed right. Really, when we started to dig into it, we realized that this traffic should actually be passing through Gorex. That would be the shortest round trip time and the best performance for this traffic. So we worked with engineers at Singaran and Gorex to change the peering so that this now uses the shorter path, the shorter round trip time path, which is Singapore to Gorex to Rayans. We saw a significant increase in performance when we fixed this, and that was just a good example of members of the community coming together to fix a performance issue that had to do with asymmetrical routing. Another example, we had internal to Asia traffic traversing the US. So we had CUHK to Beijing, passing through the US over Transpac, and they were pretty large flows. So we worked with CSTNet and HARNet to adjust the peering between those two networks so that the traffic was no longer taking Transpac. Once again, improving performance just in terms of round trip time and latency. So the team for that is listed below. This was a good example of, again, coming together as a community, reaching out to engineers that we did not know and had no relationships with, bringing them into the routing working group and working together to solve this issue. And so we hope to have even more engagements now that we have more members from these institutions actually participating in the routing working group. And then one of my favorite examples is internal to Saudi Arabia traffic traversing the US over near. So we had two universities in Saudi Arabia. Was their data transfer traffic was being seen in New York over near. After working with their engineers, we determined that this is actually currently the most efficient route, as the other option is a commodity link between the two institutions. This is an interesting example because technically the problem is simple, but it's not a problem that engineers can solve yet. But the next steps, KAUST has actually made significant progress in working with the local NREN in Saudi Arabia to improve this data transfer instead of using that commodity link. It also allowed KAUST to add their data to NetSage and improve the relationship and the collaboration that the KAUST engineers have within the routing working group and within other engineers in the international community. This one was actually discovered in NetSage. So we went and took a look at two institutions that were in Saudi Arabia. I just happened to be poking around one day. In order to look at this traffic, I said, well, that's a lot of traffic. I wonder what sensors it's being seen on. What I mean by sensor is NetSage has sensors on routers in any place that they're getting data from. So in this case, they're getting data from the near New York, Copenhagen, Amsterdam link in New York. And we're seeing all of that 88.5 gigabits going over near. So this is, at this point, this was just in the past 3 weeks. So this problem is still occurring. So when I talked earlier about cases that are on hold due to pending links or pending changes. This is a good example of, we haven't given up on this case, and we're still working with CAUS to see what we can do to improve this flow and see what we can do to assist with any of their issues with maybe potentially fixing this, or anything we can do to assist as a routing working group. Engineers from CAUS are now actively participating in the routing working group as well. So this case will continue until we see this solved, and then we'll call it closed, which is exciting. As I said earlier, we have 2 new cases in 2023. This one actually came through on Slack. So we use email, Slack, the routing working group list, a number of ways to communicate depending on how the case comes in, whether it's Slack or email, and who the engineers are and their best mode of communication. So this one came in over Slack. It was European entrants not able, Argentina not able to access, or European entrants not being able to access a device in Argentina. As you can see, I highlighted there, we determined that it was a routing loop. I've highlighted in red where the routing loop is. As you can see, it's just bouncing back and forth between these 2 IP addresses. Those two work together with engineers in Argentina, and the trace routes since February 10th have shown that the loop is fixed. So this was a shorter case that came through on Slack, but still had the same impact of solving a problem with routing in the international community quickly and helping to identify the parties that could really investigate this and help to resolve it. The next one is Japan to France via the US. So we have several institutions from Japan to Renata, which is in France, traversing the US via Transpac. This is not the least, this is an acceptable path. However, the other direction, France to Japan, is routing over CAE1, which would be potentially a little bit more efficient, and which is connecting Asia and Europe, in case you didn't know what CAE1 was. So the next steps will be, again, working with the Japanese engineering team to see if we can take a look at some of these routes and move them over to CAE1, or determine if there's a reason that they're taking Transpac over CAE. So this one is still open, but we're actively working on it as we speak today, and we hope to get more cases as this year goes along from the community, for me investigating, and then also from the community as they come in through Slack or email.
Okay. So I'm from APAN55, and I have heard from the wide, and we confirm that going through from Japan to the Grenada, for example, for this case, should be going through the transport, because has more latency advance. So the opposite direction is kind of the wrong case. So I guess we need to actually work with the Renata, and the wire itself is traversing through the APAN-JP. So I guess it should communicate in somewhere in Europe, I guess, in this case.
Yeah, it's very hard to hear what you're saying. Sorry if there's a lot of feedback, but I think we can certainly start this on an email conversation, and we can figure out the next steps. Because I certainly cannot hear what you're saying. I apologize.
Oh, sure. Okay.
But my contact information is in this slide. So let's start up a conversation over email and see what we can do to do next steps for this. How's that?
Right.
I apologize. There's just a lot of feedback from I believe in the room. So this is the NetSage dashboard that I saw this on. You may be interested in this as well. So these are some of the institutions we saw in the direction going to Renata over Transpac. So it's quite a few flows, and 130 gigs, pretty large flows. So something we should definitely take a look at, and happy to take offline on email. So feel free to contact me after the session, or even right now, and we'll get that started. We've done quite a few tool talks as well through this group. So as we say, we have the 18 cases that we've worked on, the 2 that are open. And then we provide tool talks every couple meetings. So we've done manners, router proxy looking glass, peering DB, perf sonar, microdep, NetSage, developing a collaborative BGP routing analysis diagnosing platform. And then RIPE Atlas, as I said, came a few weeks ago. These tool talks have been great for the community. As I've been saying, since we started this group, we have a lot of new R&E network engineers, and we have a lot of R&E network engineers that are retiring. And it's important to educate the next generation of new R&E network engineers, not only so that they can see why this type of networking is different than commodity or service provider internet, but also just make sure that they understand BGP and some of these other ways that they can troubleshoot. And that's why we as a routing working group think these tool talks are important and useful, and we hope to continue providing them. So if you have any interest in providing a tool talk, or someone who may be interested in providing a tool talk at the routing working group, feel free to reach out. We're always looking for new tool talks. So upcoming meetings, we have today's meeting, which I was supposed to be in person for. Apologies again. March 21st, Steve Wallace will do the Internet 2 routing initiative. I know he's talked a lot about this within the community, but a lot of people haven't heard about this yet, and it's a really cool initiative, and really aligns well with some of the work that we're trying to do. April 18th, we're hoping to do some case overviews and updates and discussion about either inefficient routes that we're seeing or trends that we're seeing within the community. May 23rd, I'm hoping to do another tool talk, but that is TBD. And then in June, we will be meeting in person, assuming no travel issues at TNC. I have applied for a meeting room there, so the date will come out as soon as we know that date. So if you are not on the routing working group list and want to go to some of these meetings, please reach out to myself, Warwick, or Hans, and we will get you added to the list and get you added to those meeting invites. My final sort of takeaway from this would be, if any of you know of existing routing issues that we should be discussing or should be added to our list for investigation, we are very interested in hearing from you, having you join our group, or even just send some of the cases to us so we can look into them and work on the troubleshooting skills that we're working on through the routing working group. And then, as I said, if you or your organization are working on any projects that you would like to present to the routing working group, feel free to reach out to us, as we are always looking for more tool talks, more members of the routing working group, and overall more discussion within the routing working group of some of the trends that we're seeing in R&E, so that, like I said, we can be more proactive and less. We're always going to be reacting because we are network engineers. If there's a problem, we react to it. But there's also this aspect of being proactive and seeing some of these issues before they become a customer issue or an end user issue, before you hear about it from the researchers or the professors or the people that are trying to actively use your network. So let us know if you have any interest in joining or any routing issues to discuss, as well as tool talks. And then we have some goals for 2023. We're going to continue to work on our routing cases within the community. We want to have a larger focus on IPv6. We talked a lot with RIPE Atlas about that in terms of helping us determine the difference between IPv6 and IPv4 routing across the international R&E networks, the international R&E fabrics. Are there any differences? Are there improvements to be made? If there are differences, why are we seeing that? Some of those types of topics. We would also like to provide more tool talks and provide diverse tool talks. So from people that may not get enough time to present or opportunities to present, we would love to have you. And then, as I was talking about earlier, we want to create over the next year a series of community-driven BGP best practice documents using small working groups within the routing working group. So some of these best practice documents are going to be focused on BGP. Obviously, as I said, some As we have new R&E engineers coming in, doing BGP for maybe the first time, I think it's important as a community to have good resources for them, and help them troubleshoot, and also just keep best practices around for the community to check in on as we build our larger networks, as we move to 400 gig, as we really create this community of international NRENs working together. And then finally, we would love, like I said, for you to submit your cases. We have a mailing list, a Slack, and a webpage. If you are interested in joining the routing working group, please feel free to email any of these emails that are listed here. Myself, Hans, or Warwick are happy to get you connected with the right people to join the right working group and the right lists. And that is the end of this presentation. If there are any questions, I'm happy to take questions. Okay, sounds like there's no questions. So that was either an amazing presentation or it's just very early in Nepal. Thank you all for your time. And if you have any questions offline, feel free to reach out to me. I'll be on the app and available on chat all throughout the conference, and I'll be virtually attending. So thank you for your time. And I will let you all enjoy the rest of your time.
Wondering who's talking back at me. And also, what do we want to do? I think you have heard from Brenda about the success in solving some of the problems. I think we have members from the routing working group down here. And so maybe you can open the floor to what you think you want the routing working group to do. I mean, Sato-san from KDDI has been very active with the routing working group. Simon from Singaran, Andrew Howard is there, and we have people from ESNet Chingyok. So we have a wide variety of people down here. I mean, if you want to, and we have Carls as well. They are from Carls. So you see, we really have this opportunity, and let's open the floor. And if you have something to say or something to suggest, maybe this opportune time to take it. And I open the floor. Andrew, anyone? Okay. Do we have a mic? Okay. Yeah.
Hi everyone, I'm Andrew Howard from the National Computational Infrastructure, which is one of the supercomputing centres in Australia. If I could just reinforce Brenna's comments on having perf sonar and a number of other instrumentation capabilities set up, it really makes our job a whole lot easier in terms of determining asymmetric routing, looking at data flow problems, particularly if you're trying to transfer data into a national HPC facility. If not, it really makes it quite complex for us to chase down everyone in the path. As Brenna said, IU is kind of the single central point of contact for a lot of the routing analysis, and I'd really suggest that you reach out to them if you are seeing particularly asymmetric routing, which has been kind of one of the common problems in our community for the last 20 years or so. It's really easy to get an AS or an MPLS path configuration issue that you might not be aware of, and it may take a number of weeks until one of your high volume users actually starts reaching out for help. So running a perf sonar mesh, I think, is really essential, and something that I'd encourage everyone to set up.
Yes, indeed. Engineering. Yeah, any comments? Sorry, unfortunately, the people because they handle large network.
Yeah, actually, there might be some routing issue, but not like the big one mentioned by the Amina, right? The speaker. Actually, sometimes we can see some asymmetrical routing issue, but so far we haven't got some much complaints from our customer networks. Maybe our NRAN is not quite not quite sensitive to such kind of issue. So for me, maybe sometimes we can try to we for 10 backbone we have quite a number of existing 12 NRAN and for the routing sometimes it's just a little complicated. But for the main mirror flow, for example, to the Europe or to the US through the Japan and to Australia, that's looks okay. And for instance, in China, we have another big partner, CSTNet. He has some big flow. That's because they have their own interconnection through Hong Kong to US. But it seems that link is not in good performance, so they just selected to take the 10 backbone through Beijing, Hong Kong, and then to Japan, then to US, something like this. So maybe that's some that's not a optical route, but that's what they need to do. So maybe sometimes for the routing issue, something is maybe made by mistake, but something maybe just for their purpose, special. They have some particular requirement on that. That's my opinion. Yeah. Thank you.
Also, the subsea cable systems we run under, experience sometimes long-term cuts. So if I just reinforce, there may be specific reasons that someone has chosen to direct a different path that is not the obvious path to
kind of an old school network engineer. So we need to kind of be aware that it's an ongoing and fluctuating situation in terms of what cable systems are available or operational at any time. So you may need to be manually doing part selection to work around a particular problem.
I think that brings us to another point. We have multiple cuts between Singapore and Hong Kong, and Singapore and Tokyo, and we have to route our traffic. Maybe Sanderson, you want to say something about that?
Yeah, actually, the offense multiple subsea cable cuts across. So the as APAN55 or the other NOx, we will try to keep the connection as much as possible by rerouting somewhere in the Pacific area. But it doesn't work for someone. Some person don't want to do this. So that's kind of the point would be the next step for our community as a whole to discuss, I guess.
Yeah, I think what I'm saying is that just now you saw a very nice picture of APONET across across the Pacific and Oceania. If you think that we wrote a MOU among the multiple parties, about 11 parties, to back up each other's traffic across the Pacific, and it has worked very, very well. And it has worked very, very well because we have a lot of paths going from East Asia all the way across the US. If you think that you have 2 links, that's enough for you for resilience, then say that's not quite enough. We found 2 of our links broke, and if we didn't have the part that goes down to Australia and Guam and go back up, we would have been quite badly cut off. Southeast Asia will be quite badly cut off from the US. The alternative, you go by routing only, it will go from Singapore to Europe and go around the other way to the US. So routing, it's always changing, but we have to make sure that our backup works as they are supposed to be. And routing is critical for us. Hi, Kevin.
So I guess I should address the poster child that Brenner used as to the benefits of the working group.
Maybe you want to introduce yourself first.
I'm foreshadowing. And that is the network within Saudi Arabia. Obviously, I represent KAUST, so not an NREN, just an institution. And this working group is rightly focused on routing efficiency. But there's another aspect that I think we need to consider when we look at the routes that are chosen, and that is financial efficiency. So it is madness, and it is absolutely crazy that today the most financially viable way of transferring data from KAUST, an institution near Jeddah on the Red Sea of Saudi Arabia, to KAXT, an institution in the center of Saudi Arabia, 500 miles, 600 kilometers away, is via international links. To give you an idea of the context we're working in with local operators, it is 40 times more expensive for me to connect domestically than it is for me to leverage the international links that we've managed to create. So yes, we are the poster child right now for inefficient routing, and it makes for a great story here. The flip side of that is we are also the poster child for financially efficient routing. And what I look for from the NRENs in this room is to continue to lobby your governmental organizations and your contacts within the decision-making community to lean on the telecom providers, as you already are in a lot of your home institutions, to continue to allow preferential rates We're doing something similar within the kingdom with our partners at CAXT. But in the meantime, we're going to see lots of strange workarounds until the financial situation regarding local connectivity improves in our region.
Thanks, Kevin. From Carlos. I think that's a major issue. Local loops can be very, very expensive if it's a monopoly. That means there's not many competition among the telcos within the country. Anyone from EU? Engineers from EU? Anyone here? I know from there's Chin Kyok down there. Do you want to say anything about? You're going to hear a lot more, but see.
Oh, okay. Oh. I'm not quite sure what to say. I mean, I think one of the key aspects of doing this end-to-end stuff that I think we do lack is the notion of being able to share information, right? Doing coordinated troubleshooting, I think it's easy. You know, you have a whole bunch of folks coming together. You got to work out the time, the time differences. But it would be nice if we actually had systems that allow us to immediately look and see what the issues are. Right. And I know that, Persona is a good example of something that's collaborative. But if, we're able to share more than that, in terms of our stats, our logs and things like that, I think that might be actually very in terms of solving performance issues, so not just routing issues.
Thanks, Chin Kyok. Chin Kyok is actually CTO for ESNet, major US network down there. Anyone else who want to say anything? Konishi-san, yes? Yeah.
I am Kazunori Konishi, APAN55, and in our days, for example, KoreaNet didn't have a route in Asia. They concentrated to connect to North America and Europe. KoreaNet is a very big network, but they didn't have a routes in Asia. This was caused a lot for US people. All traffic from KoreaNet to Asia is via United States. But thanks for the connection from KoreaNet to Hong Kong, we paired with KoreaNet and we provided the Asian routes to KoreaNet. And the most difficult situation has been overcome by our peering and routing. And but these days, today's Brenner made explanation, 2 cases or 3 cases. These cases will happen forever. This is the issue, how we should concentrate the job to improve theoretically or engineering point of view. Well, every meeting, today is good, but every meeting we will hear from one point to the other. This is the issue, very broad routing. But it's very important for APAN or Asian community to have a set up a backup route via, for example, from Japan to Guam to Australia to Singapore, for example. This is very good for us. Backup routing is set up, and because cable stability, availability is not so good in Russia, especially in Hong Kong area or Singapore area. Many cables are cut off. Roughly one cable, maybe 50% or something is cut down. And that's why backup route is bad for us. And this is another issue, routing issue. Okay. We didn't discuss on the improvement of the backup route. Probably Sato-san will make a presentation here or no, how we can we set up a backup route and the availability to connect to point to point. How much improved these days? Not only the performance, but the connection is more important than routing in a sense. But best performance routing is the second one. Connection is still number one issues for us. This is my comment. Sato-san, could you explain how Japan, Guam, Australia, Singapore, link have improved a lot for our operation? Thank you.
Actually, it's gonna take 20 minutes or so. But yeah, we have the more than, I guess, the more than 5% between the Japan and Singapore. Japan, Hong Kong, Singapore, that is one, and Japan, Singapore, and the Japan, Guam, Singapore, and another Japan, Guam, Singapore pass, and another Japan, Guam, and via Australia, and then go back to the Singapore, and another one is Japan, Hong Kong, Korea, and Singapore, and we will give you another Japan, Hong Kong, Singapore circuit, and you'll have the Hong Kong, Singapore safety net circuit, so they're just too many.
Well, you want to find out more about it, come for our network workshop tomorrow and find out more about it, because you'll find out, in actual fact, the community has come together to sign the MOU, not just for the sake of signing an MOU, but so that we can back up each other. That's number one, And secondly, inside the MOU is also to encourage collaboration, research collaboration among the communities, with communities in the US, with Europe. But we must come together as a community to work together. The network is there, but we need you to use it. Okay? The network is just only the first level layer. Routing is the second layer up there. We will try to make it as efficient as possible, subject to policies. Sometimes there are some policies, and that's why they are routed that way, And on top of that is your applications, your collaborations, and that is important, okay, to drive that. So do come to our working group workshop tomorrow morning, 9 a.m. This place. And you'll hear more about it rather than just me standing up, we standing up here for to share with you. You see the PowerPoint and everything. Hi, Andrew.
If I could just reinforce both Kanisha Sensei and Francis's comments. As a community, we're able to solve all of these problems, but it's really important that we know each other, we know who to reach out to at a particular location to try to start troubleshooting, because it really needs to be coordinated potentially across multiple continents or multiple paths. So get to know the people, attend the sessions, make friends with people. It has served our community so well for the last years, and we need the new generation of network engineers to know and trust each other and know when a real problem is being reported, rather than and so everyone can be involved in fixing it.
Eric, you're from Taiwan and you're a major user.
Yeah, major user as a service provider for various disciplines of sciences. I agree to all the comments from before. Just one thing, that the reliability and efficiency of the networking infrastructure are the common goals for us to working together. Thank you.
Thank you. I think during the network workshop, I think Simon will be sharing about what's happened and where our backup routes went. And it's amazing. You get a delay, but I mean, submarine down cable can be few months it's down for a few months. How can we afford that downtime? So that's to share with you. But do come for the network engineering workshop, and there's a lot of sharing down there. Anyone else? Yeah.
Something else that I could discuss is the Data Mover Challenge, which is conducted by the National Supercomputing Centre of Singapore. Basically, we're looking for new tools and techniques to improve data flows, particularly between HPC centres. We've seen some remarkable amounts of data flows, particularly coming out of CERN, that our communities rely on, out of the European Space Agency Sentinel program, out of the US, and some of the emerging telescopes like the one in Chile. So this is a kind of an evolving issue, and as Eric mentioned, this is absolutely vital for our researchers to get the data in a timely manner. So, we'd like to open and invite anyone who has any new or innovative techniques or thoughts on tools that we can be using for data flow improvement. We're hoping to be able to take the experience of the Data Mover Challenge and actually expand it into our production services going forward globally.
Andrew. Yeah, the Data Mover Challenge is coming online, I think, very soon, next month. Okay.
Hi. For all who don't know me, oops, sorry. My name is Frédéric Louis, and I'm from Europe, France. And I was just mentioning that we are involved in various international projects like LSST. So if there is any problem related to LSST connection between CCIA and 2P3 and all the other sites, just let us know, and feel free to reach me. Okay. First thing.
Yeah.
Second thing I saw in the slide, it was related to Renater, Japan, KDDI routing issue. We can obviously discuss about that. So also I will be your point of contact.
Okay.
And because we are working right now with ITER project, because they are located in the south of France, and technically they should have a 100 gig connection directly from Cadarache in the south of France all the way to Geneva, and normally it should also go to to Japan. So this is the second thing, and we are working with Bruno from with LSC1, and so basically, how we are doing things is that we are trying to. The whole problem we can see now is bad coordination. Bad is maybe hard word because it's not so bad. But when as you said, we had an outage somewhere, we cannot afford to send a mail and just send a bottle in the sea and just wait the answer. We really have to have a kind of lead time to notify the others who are involved in the end-to-end circuit, and this is where I would say where we lack of information, at least from our perception.
So can you? I'm not. I do not quite understand the scientific project that LSCC is about. Maybe you can share a bit about what a background about LSCC to the community. Then we can see how maybe some members of the community may want to participate.
No problem. So the LSST is actually the new telescope in Chile. So usually in a scientific project, you have a research instrument. I'm talking under control of yeah, but you have a research instrument. This research instrument is usually located in a specific place, in a strategic place. And in Chile, this is not a mystery because the telescope is really high up in the mountains. And based on that, this instrument will generate a constant amount of data that has to be processed in parallel, simply because there is no local storage, not enough local storage to process it. So all of this data, raw data, has to be conveyed in specific computing center. In the case of LSST, I presume for now that it will be in Slack, and also in Lyon, in France. So some data will be deduplicated and analyzed at the same time. So this needs to be really constant, because when you have a telescope, there is no, this is a real ongoing observation of the whole galaxy. And the idea of that is to set up a parallel resilient with alternate paths, where this data can be conveyed safely and be analyzed during a period of 2 days.
Okay, thank you very much. In actual fact, data mobile challenge that Andrew just talked about, one of the data transfer node will be in Brazil, and we hope that things, and Chile is involved as well in that. So I think that will be good. What I think Andrew is hinting on is, once we deploy them, we hope to keep them and we hope to understand what is the throughput that we can achieve on the different links around this data mover challenge. Yeah.
I'm not sure if this is something interesting for you, but for example, in our case, in the Géant project, we are in the GN51 program. We are deploying a lab that is called a Global P4 Lab. And actually, this P4 Lab is interconnected via international links. And the particularity of this equipment is that it is affordable. And just as an example, with I would say for $5K, you can have a node that has a 32 ports at 100 gig USF pin 28, which is quite interesting. And you can connect any DTN on that. And I think that I'm working with Marco Schwarz.
Yes, I was talking.
And we have a DTN connected to this P4 switch. So from that point, you can reach any POP that has a P4 switch. For example, in Kisti, Tokyo, and also some nodes in Europe and in Caltech in the US.
Thank you. Yeah. I think I won't hold you back anymore. I thank you for staying back a little bit longer and sharing your thoughts with everyone else. It's a good time to mix around, and I think it's tea time as well. So you get to know people that you may not have met before in this meeting. I think that's the purpose of the in-person meeting. Thank you, everyone. Thank you.